All right, guys, we're going to quickly take a look at projectile motion. And all that is just a quadratic in context. Okay, so what you want to pay attention is what's happening in the question. So, for example, one, it says using the graph on the right, on the left rather, it shows the height h in small feet. So, if you look at the y-axis, it should say height. So, this is height, and if you look at the x-axis, it says time. That's very important because you're going to be using that to answer the questions. All right, so height h in feet of a small rocket t seconds after its launch. So the rocket goes up and then it comes back down. Very important that you picture actually what is happening. So this is the equation. Most of the times they don't give you the picture, they give you the equation, and all you would need to do for that situation is just type it into the calculator. Now, I cannot put t in the calculator because it won't pick it up, so I do change it for x, but I do know that that means t, 128x. All right, so this is the equation in the calculator because most of the time they'll just give you the equation. They won't give you a picture, but we're going to use both. So remember, they have told you that the y-axis is height and the x-axis is time. That's going to be very, very important. All right, so the first question is, how long is the rocket in the air? So think about that for a second. If I'm asking how long something is in the air for, like if I throw a ball, I put out a rocket, how long, what am I talking about? Am I talking about the height or am I talking about time? All right, you should have said you're talking about time. Okay, so if I'm talking about time, that means I'm only looking at which axis. Which axis talks about time? The x-axis. So I'm only talking about the time. The rocket goes up, it comes down, and it's in the air for how many seconds? For 8 seconds. All right, so again, the only difference with this question is that they might give it to you without the graph. And so if they then give it with you the graph, you're still thinking about the same time. You're going to see how long is it. So x-axis is time. How long is it in the air? You're going to come and click right here and you see you get the exact same answer. So whether they give you the graph or they give you the equation, just put the equation in the calculator and then look at it. All right, so 8 seconds. All right. And then what is the greatest height? So again, now what's the key word there? It's height. Okay. So what is the greatest height the rocket reaches? What does that mean? Because remember, the rocket goes up, right? The rocket goes up and then it comes down. So what's the greatest height? Well, the tallest part of the graph is right here, which is the vertex, right? And so what is the height? So remember, the vertex has two coordinates, right? It has 4 and it has whatever number that is, which I don't know. So I'm going to come to my graph, zoom out a little bit. All right, so go to my vertex, 256, right? So it has 4 and 256. Which one of these do they want? It's important to remember what the axis is. So x is time and y is height. So I want height, so it's 256. Okay, and that's all you're doing in this problem is just thinking through what the question is asking. So what's the 256 what? It's height h in feet. So this is 256 feet. All right, how high is the rocket after 1 second? That means I go to where x is 1 and I see how high it is. And again, I can do that from here. So this is 1. I can go up and I can see that it's about 100. If I had it here on the calculator, instead of going and doing what I just did here, like looking at 1 and going to 100, how can I do it here? I can come here and I can make this a table, and then I can make x equal to what? 1. Because I want the time to be 1 and I can see it's 112. So it's really not 100 actually. It's just off of 100. So it's right here. So I was going to be approximating. So go ahead and put it in the calculator if they give you an equation. So it's 112 at when time is 1, height is 112 feet. So 112 feet. Okay. After 2 seconds, so I'm going to come here. And now I'm going to put 2 seconds. It's 192. So 192 feet. Is the rocket going up or down? So at 2 seconds, is it going up or down? So let's go look. All right, so I'm going to press home real quick so I can zoom in. At 2 seconds, it's, right here. So let's go find it at that point. And it looks like it's really going up. It's really going up because when does it start turning? It turns at the vertex, right? So if I come right here and I click here, you'll see it's 4 seconds, it's going to start going down. So at 2 seconds, it's going up. And we can just put that in there. So I can say 192. So I can put the coordinate 2, 192. And this is the point right here. So you can see it's clearly going up. Is the rocket going up or going down? So this one is going up. After 6 seconds, how high is the rocket? So I'm going to come back to my table and I'm put 6. All right, so I'm going to put 6. It's coming right here. How high is it? 192 feet. So you can see that at 2 seconds and 6 seconds, it's the same height off the ground. Is the rocket going up or down? And you can see the point just came across right here. It is now going down. All right, and that's pretty much all there is to projectile motion. So I'm going to do one more example, and then you can do the last one. So I'll do example 3 since there's no graph. So again, if there's no graph, remember you're just strictly typing it into the calculator. So I'll do 3, and then you can do 2. While working on a roof, Rob dropped his hammer. The hammer fell and can be represented by this equation. Again, remember, do not put t in the equation, put x instead. I meant to put a negative right there. Please double check what you're typing. Plus 20. All right, so click home. I see the graph. So he drops the hammer. It makes sense. It doesn't start off the ground. That's why it's on negative. Very important thing about when you're doing projectile motion, it's a real world problem. Can I have, again, what is the x-axis? Time. And then what is this? Height, because he's dropping the hammer, right? So can I have negative 1.11803? No, because I can't have negative time. Okay, so technically the graph does not even exist on this left-hand side. But anyway, let's go ahead and answer some of these questions. How long will the hammer take to hit the ground? All right, so the hammer is dropped from a height of 20 feet is what it looks like. And then it falls, and then it finally hits the ground here. And how long did it take? 1.11803. All right, so how long did it take? All of these seconds. Now, usually they do need to go ahead and tell you rounded to rounded to the nearest something. Nearest. Let's say 10th. All right, so I'm going to go ahead and teach you how to round in the calculator. So I'm going to make some notes here. Please definitely write this down because this is the first time you're doing it in the calculator. What you're going to do is you're going to tell the calculator, hey, calculator, I would like to round. All right. Calculator is going to ask, okay, well, try using parentheses. Tell me what you want to round. I want to round this number here, which is that. And now you got to tell it what you want it to round to, okay? So we're going to make a couple of notes. So if I say I want to round to the nearest whole number, this hash means number, that will be no decimals, okay? You'll see this is the nearest whole number. There's nothing there, right? So you see all of this is gone, right? So nearest whole number, you just put it in the calculator as round. All right, so no decimals. Nearest, actually, we're not going to keep writing nearest 10th. I'm just going to say it. 10th, all right? So again, the way I remember this is you're simply going to look at how many zeros do you see? 1. So nearest 10th, you're going to do comma 1. Because you want one number after the decimal. So if I wanted nearest 10th, I would do comma 1. And notice it gives me one number after the decimal. All right, if I wanted nearest 100, so nearest 100th, right? Again, notice how many zeros do I have there? I have 2, which means I want 2 numbers after the decimal. So if I come right here and I put 2, you can see that it's giving me 2 numbers after the decimal. If I want the nearest 1,000, all right, how many zeros do I have in 1,000? I have 3 zeros, so that's going to be 3, okay? So you're just simply telling the calculator. And even if you don't remember, just feel free to play around with these numbers, and you can look because it's visible, right? So in this question, it asked me, how long will it take the hammer to hit the ground? Round it to the nearest 10th. So I want to say, okay, how many zeros are there in 10? There's only 1, so I'm going to put 1 right there. So 1.1 second. All right. Now we are going to answer some other questions because I want to make sure I cover everything. So that's how long it took to hit the ground. Let's ask. So we're going to ask here. Let's say B. Greatest. Yeah, let's write greatest height. All right. So what was the tallest the hammer ever was? So that's going to be the vertex. And how tall was it? This is time. and this is height. So it was 20, and again, is this feet? What is this? Height in feet. Yeah, greatest height is 20 feet. So we're just practicing some of the questions that they would see. C is time for greatest. Greatest. Okay, height. All right. How high was the hammer at the greatest height? At 0. You can see the time there is 0. So at 0 seconds. So height 0 seconds. All right. What are the questions? How long did it take for it to hit the water? How high did it jump? What time was it? Okay. And then randomly they'll ask like how high is the ball at 1 second or whatever. And so remember, for that, all you're gonna do is make it a table. You hit settings, table, and whatever time they're asking for. So what was the height at 3 seconds? Negative 124. So obviously, the ball's already hit the ground. Can I have negative 124 height? No. So at 3 seconds already hit the ground. So let's see what's the 1.1 is the furthest. So I guess they could ask how high was the ball at 0.5 seconds? Okay, it was at 16 feet. All right, so that's how you do projectile motion. So please go ahead and put it in the calculator if they give you an equation. All right, please practice example 2. Let's practice.